guys. So I know that AP exams are coming up for people here pretty soon, and I wanted to go over this AP AB calculus question from 2019. It's a free response question. No calculators are allowed here. So I want to go through how would you solve a problem like this. First of all, let's go ahead and take a read what the problem is asking us. So it says the continuous function f is defined on the closed interval from -6 to 5. The figure above shows a portion of the graph of f consisting of two line segments and a quarter of a circle centered at the point 5, 3. It is known that the point 3, 3 minus root 5 is on the graph of f. If the integral from -6, to 5 is equal to 7, find the value of the integral from -6 to -2. Show the work that leads to your answer. So that's where we're going to begin. And so the first thing that I'm going to do is I'm just going to write down what we're being asked. We're being asked to calculate the integral from negative, hold on. First I'm going to write what we, I don't think white is a good color, so let's try pink. We are given that the integral from -6 to 5 of the function is equal to 7. And this integral can actually be broken up into two integrals over the interval, and we're going to break it up conveniently at -2. So that now we can calculate what we're being asked for, right? We are being asked to calculate this piece. This is our question mark. And this one we can actually get from the graph. We can look at the geometry of the graph there and calculate that because we're given the graph of f from -2 to 5. And this one is the piece that's given. We're told that this is equal to 7. So if we can rewrite this function, or sorry, this equation, put this piece to the left, then we will have our solution for this one, right? So it's just as simple as saying 7 is equal to x plus y, and then subtract y from both sides. 7 minus y is equal to x, and x is what we're looking for, right? So it's kind of like that idea where we're just solving a one-step equation here. So let's write that down. 7 minus the integral from -2 to 5 of f of x dx equals to the integral from -6 to -2 of f of x dx, right? And so now look at what we've got. We've got 7 minus this integral is equal to what we're looking for, right? That's what we're asked to calculate. So as long as we can calculate this integral by using the graph given, we will know the solution. We will have answered the question. So that's where we need to do some thinking and break apart this picture that we've got to figure out the integral. Remember, integral represents area under the curve. So let us shade in the area that this integral is going to represent. Right, we've got this line segment, area under the curve here. It's going to be that red piece, right? Let me use another color for the next piece. We've got this area underneath the x-axis that's going to be included. And then we also have the area from 1/2 to 5, that piece. And so we've got 3 pretty much intervals, 2 of which are positive area, and 1 of which is negative area. So now let's look let's look closer at each of those pieces and see if we can figure out what is the exact area under the curve. Let me use orange. So for this piece, from -2 to -1, if we look at that, the area under that curve, we recognize that that area is in the shape of a triangle. And the area of a triangle is just 1/2 times base times height. This triangle has height 1, base 1. So this triangle's area is just 1/2. All right. So I'm going to start writing down the area right underneath this integral. So far I've got that 1/2, that yellow one, taken care of. Now for the next piece, let's use, for the next piece, I'll just look at this one. Here I have also a triangle, so the area is also 1/2 base times height. And I just got to look at this to check out what's the base, what's the height. The base is going to be this length here, 1, and then the height is going to be also 1. So this one also is 1/2, but it's underneath the x-axis, so it's a negative area, -1/2. All right, and we're going to continue on like that. Let's keep using different colors here. The next piece is another rectangle. Sorry, triangle, not rectangle. Base 1/2, height 1. So this one's going to have area 1/2 times the base is also 1/2, and the height is 1. So that little teal triangle is going to have area -1/4. All right. Now let's continue on. Let's use orange again. Next little triangle, this guy right here has base 1.5 or 3/2, and the height here is 3. So that area there, I'm going to use this space right here, 1/2 times a base of 3/2 times height 3. The area there is going to be 9/4. So we're adding 9/4. And lastly, let me try that again because that didn't look good. That didn't look too good. Plus 9/4. And lastly, we want to calculate this little piece. The area under that circle, under that portion of a circle. The thing is that for that piece, this isn't a triangle anymore. Yeah, it's no longer a triangle. So it's not that easy. It's not just, 1/2 base times height like the others have been. I'm just going to erase this because we don't need it. So your options are to figure out what is the equation of that circle and then explicitly calculate the integral of that equation from 2 to 5, or that function from 2 to 5. So what I mean is express this circle as some function f of x And then you can explicitly calculate the integral, the value of the integral from 2 to 5. That's an option. But using geometry is another option, and it is a lot more quicker, probably, uh, less room for error with if you just use geometry, because we all know that integrals are they can be trickier, and the algebra involved can allow us to run into issues. So as far as what I mean by using the geometry of the picture, what you could do is you could consider the area of the rectangle that I outlined, the area that uh, the area into which this circle is embedded. Find that area. The area of this of the square it's a 3 by 3, so the area is just 9, right? And then subtract off the area of that portion of the circle. Subtract this piece off, and from there, that'll give you this little portion. So that's my little trick with how to use geometry to calculate that blue area. This orange area is going to be 1/4 the area of the circle with this given radius, with the radius of the circle. So we need to know what the radius is, right? We need to think about that for a minute. What is the radius here? So I'm going to erase this so we can have a clearer picture. What is the radius of the circle? Remember, area of a circle is pi r squared. So we need to know what the radius here is. We are told that the center is 5, 3. All right. One other point on the circle is this one. This is 2, 3. Okay, and if we look at the distance between the center of the circle and any one point along the circle, then that will give us the radius. This is a length of 3. So our radius is 3. Right, so the area then is 9 pi. Okay, and so then we can write that into here. Area is 9 pi. So we now know the area underneath this portion of the circle. It is 9 minus 1/4, 9 pi. So we're going to put that in here. Plus 9 minus 9/4 pi. From there, we can start simplifying this massive expression. 1/2 plus -1/2, that's going to be 0. -1/4 plus 9/4, that's going to be 8/4. Right, this piece, 8/4. And then that's going to be 2. So I'm going to erase this here. Right. This is going to be 2 plus 9. It's going to be 11 minus 9/4 pi. And so that is the area under the curve from the interval on the interval -2 to 5. It is the value of the integral of f of x dx from -2 to 5. So now we're just going to solve for this integral, the value of the integral of f of x dx from -6 to -2. -7, 11, +7 minus 11 minus 9/4 pi. We can open up the parentheses. We're going to have -4 plus 9/4 pi. And then we are going to write a solution as just writing the positive number first. 9/4 pi minus 4. That's going to be my final answer for part A. All right. Hopefully this video helped you out a little bit. Comment in the section below if you want to see part B, C, and D. And good luck with your studies, and I will see you in the next video.